Hello students. Today we are talking about the new lectures on the transportation problem. That is, in this video we just try to listen the only introduction. What is the transportation problem? What is the feasible solution of the transportation problem? And under what condition the feasible solution of any transportation problem exists? Okay, whether that solution is optimal or not, that is not we discuss in this video. Only we will discuss under what conditions are there. So firstly, that is the introduction part. That is in the application of the linear programming techniques, the transportation problem was probably one of the first significant problems studied. Actually, in our day-to-day life, we always see that the number of the products or number of the goods are transported from one place to the another place. Okay, or moreover, once we are itself we itself move from one place to another place. So whenever any product is transferred from one place to the another place, there is a involvement of the several factors are there. For example, there is a manpower, there is a transportation cost, okay, and so many others are there. So in this, that's why this particular problem, in such type of the problem, we will discuss about the transport. That is the meaning of the transport, that what is the impact of the transport onto the programming problem. Okay, so this problem can be expressed as a formulation of the linear model. Remember, this is a linear, okay, and can be solved by the simplex method. But in the next uh, uh, in the couple of the slide, I will explain you that it is very difficult to solve with the help of the simplex method or big M method or the dual simplex method. Okay, because there are the several factors which are associated with it. So in this video we will discuss all those methods which are beneficial for solving such type of the problem. So for example, I just firstly explain the meaning of the real transportation problem, and then just explain the mathematical models and the terminology behind it. Say, suppose that a company manufacturing the air coolers that has the two plants situated at the Delhi and the Jaipur, which has the capacity of the 3000 and the 300 and the 100 units per week. Okay, so it means I have the two units, that is, one is the Delhi and second is the Jaipur. Okay, they have manufactured certain products of the air coolers are there. So what is that? Once they manufacture that, then definitely they will transport their air coolers to the different stations. Okay, so the company supplies the air cooler to its four major showrooms are there. Say, for example, this one showroom is in Patiala, second is Kolkata, Bangalore, Chennai has there, and the maximum demand for this Patiala is 40 units. Kolkata is 160 and 140 and 60 for the Bangalore and Chennai respectively. So what will happen? Since the Delhi has the different raw materials, different manpowers are there, different working and all other conditions. Similarly for the Jaipur also, they have the different manpowers, they have the different raw materials and so on. So definitely there is a technically slightly change in their air coolers models are there. So what will happen? So due to the difference in the raw material cost, transportation cost, the profit per unit per rupees differ, which are quite obvious that, for example, the air cooler which are designed in Delhi and transport to the Patiala, the profit will be 100. While similarly, if the air cooler which are manufactured in the Jaipur plant, they transport to the Patiala, then the profit will be 89. It's quite obvious because Patiala is near to the Delhi, so the transportation cost is less as compared to the Jaipur, so the profit will be high. Similarly, for the Delhi to Kolkata, Delhi to Bangalore, and these are some profit per unit per rupees are there, which are definitely differ from city to city and from the manufactured plant. So the question arises is, so what is that? The daily capacity of the Delhi is 300. So maximum they have to 300 units per product. For the Jaipur, they have the maximum 100. While for the Patiala, the maximum demand is 40. While for the Kolkata is 160, Bangalore is 140, and here is 60. Okay. So what is the meaning of them is the Delhi has the maximum of the 300 air coolers, and the Patiala restriction is 40. The maximum 40 air cooler they can buy them. So from where they can buy? Either they can buy from the Delhi or from Patiala. It may be that he can buy 40 unit directly from the Delhi, and there is no unit buy from the Jaipur, or he or they can buy 20 units from the Delhi or 20 units for the Patiala. Okay, or any other any other combinations are there, 10 and 30, for example. And on the other hand, if the Patela buy the 40 units directly from the Delhi, it means the remaining 260 units are distributed among the Kolkata, Bangalore and the Chennai, while 100 units are completely distributed in these products are. So such type of the models can be formulated with the help of the transportation. Okay, so in general, so if I say there are the here in the previous case there are only the two sources. One is the Delhi, second is the Jaipur. So in general, if I say there are my M sources, these are my M sources. So here are my sources. Okay, O1, O2 and up to the M sources are there, and their target is to transport their products from the one source to the destinations are there. So here I just consider there are the M n number of the destinations are there. Okay, and what is the C11? That is a cost. What is the C11? Is the cost, that is the transportation cost of the source 1 to the destination 1. Okay, that is the C11 transportation cost, that is bring from O1 to the C1. Look at the previous one, this is my C11. Okay, that is 100 C11. So C11 means that is nothing but C11 is means you have to transport the cost from the city, from the uh, uh, plant Delhi to the city Patiala. Okay. Now similarly, C12 is the transportation cost of the source O1 to the D2 and so on. Here A1 represents the maximum supply by the source O1, AM represents the maximum source of the OM, and this B1, B2 and they are representing the demands. So this is the matrix format because this is represented in terms of the matrix are there. So how many variables are there total in this format is MN. Okay. So in order to represent in the model form, so if I just consider these are my sources O1, O2, OM, OM, and these are my destinations are there, and each source can send their products to each destinations are there. So that is this and this. Similarly, O2 and so on up to ON are there. So when the one source O1 transport the units to the destination 1, the transportation cost is C1. Okay, here X11 represents the number of the products transferred. Okay, so I know that there is a transportation cost from one source to the one destination is C11. So the question arises is how many units we can transfer or we can transport from the one source to the second source is denoted by X1. So in general, I call as Xij is representing my number of the units, that is transport, number of the units transport from ith source to the jth destination. Okay, so and similarly Cmn is the cost when you transport from the M source to the nth destination, and Xmn represents the number of the units we can transport in such case. So based on it, we can generally define, because our target is to transfer the products B. So definitely when you transfer from product A to B, there is a cost Cij, and your target is to minimize the cost B. Okay, so what will be the total cost B? So if I say this is my C11, this is my C12 and so on, and up to Cm1 and Cmn. Okay, so when you transfer when you transfer say X11 products from the source 1 to the destination 1, the cost will be C11. So the total cost will be C11 X11. Similarly, the cost for transfer of source 1 to the destination 2 is C12, and I assume that there are the number of products are X12. So the total cost will be this one, that is this plus this, and up to last one is Cmn xmn. So what are the restriction on that? That is the maximum source. Here look at that, the maximum source of this, here the maximum source of O1 is A1, the maximum supply of the O2 is A2. This is the maximum supply. Okay, so it means the constraints are, you have to put supply x11, x12 and so on, which is the less than of this, and second for the greater, because this is the demand is there, and xij are greater than 0. Okay, so since this contains some inequality or equalities are there, so when you transfer to the standard form, so nothing but there are equality signs are there, including slack, surplus, artificial, or whatever is there. Okay, so that is the minimization of this and so on. So now when you know that this is the standardized form, so you can solve it with the help of the simplex method, dual simplex method, graphically, or any other methods are there. But what are those drawbacks are there? Look at that. I just consider this as a transportation problem, in which I just consider as the three sources and the 2 destinations are there, and 3 these are my costs. Okay, and these are my supply, this is the maximum supply, and these are the demand of the destinations. So look at that, what is the objective function is C11, that is 4, number of the unit we can transfer from the 1 to 1 is 1 1, so 4x1 1 plus 3x12 plus this, so this is my objective function. What is the constraint is 4x1, because this 2, that is the supply of the source 1 is 2, can be split up either as here or both of them, that is 1 1, 1.55 and so on. So the constraint is x11, here the number of the units you have transformed is x11, so x11 plus x12 is equal to 2b. Similarly for the second, x21, x22 is 5, x31, x32 is 3. Similarly for the column wise, this is my x11, this is my x21, x31, so x11, x21, x31 is nothing but the 5, and similarly for the others are there. Okay, now when you try to solve this with the help of the simplex method, so look at that, how many variables are there, so x11, x12 up to the x32. Okay, and other slack or surplus are there, there is a set. So when you try to solve this is there. Okay, so these are this one. So look at that, how many variables are there in this simple example, that is a 3 cross 2, that is a 6 are there. Okay, and number of the basic variables are 4, so this I just calculate here as m plus n minus 1. Here m is the number of the rows, n is the number of the columns, and n1 is r. So 3 plus 2 minus 1, that is nothing but the 4. Or otherwise when you substitute here, look at that, x11, what is the column of the x11 is 1, 0, 0, this is 1, and here is 0. Similarly, what is the x12, here is 1, this is nothing, this is 1, this is nothing, 0, this is nothing, 0, this is nothing, 0, here is a 1, and so on. So look at that, the problem is very complicated, very complex is there. Okay, and so on. So in either case you have to find firstly this and so on. Also we can see that since all are the equality signs, so from here you can find the value of the x11. So what is the x11 is, so you can find it as 2 minus x12, and you can substitute here. Okay, and so on. So that's why this is a very lengthy method. So in order to solve it, there is some methods which is involved in the transportation problem. So we will study on that. So what will we do is, first question arises is whether any feasible solution exists to the transportation problem. Remember, we are not talking about the optimal solution. Firstly, because optimal solution occurs when there is at least one feasible solution. So first question arises obvious, that is there any existence of the feasible solution in the transportation problem? If my problems are look like, say, this is my problem, okay, or this is my problem. So whether there is existence of any feasible solution or not, because if there is an existence of the feasible solution, then we may try to move on the optimal solution. Okay, if optimal solution exists, then it's okay. If optimal solution does not exist, then we call it as the unbounded solution. So but here the question arises is, if optimal solution exists, if the answer is yes, then under what conditions. Okay, so first thing is that when the feasible solution exists, is that the answer will be here. The necessary and the sufficient conditions for the transportation problem to have the solution is that total demand is equal to total supply. This one. Okay, so look at that. If I just consider this example, this is what is the total supply is, that is a sum, that is my 10. What is the total demand is, again 10. Okay, so if both are equal, then there is a guarantee. Remember student, there is a guarantee that at least one of the solution is the feasible. Okay, so look at that, this is the feasible. Okay, but remember that such conditions may not always be hold. For example, for very recently a lockdown period is there. So what is that? There is a huge demand, but the supply is less. Okay, so there is a huge demand, but supply is less. On the other cases, in the normal days, it can also be there. Sometimes the demand is very large as compared to the supply. Okay, or sometimes the demand is very less, but supply is the huge one. Okay, so in such case, there are the two cases. One is that whether this constraint satisfied, or either this constraint violates that. Okay, so that's why we just discretize the transportation problem into the two types. One is the balanced transportation problem, second is the unbalanced transportation problem. So balanced when the total supply is equal to total demand. Okay, and on the other hand, unbalanced problem when the supply is not equal to the demand. Remember, this is the total supply is not equal to total demand. So remember, whenever you are trying to solve the transportation problem, you have to firstly convert the unbalanced transportation problem into the balanced transportation problem, always. Otherwise, there is no guarantee for the feasible solution. Remember the last slide here, there is existence to here the necessary and sufficient condition only when this satisfied. And what is the condition for that? This satisfied when? If this satisfied, it means the problem will be a balanced one. So always, whenever there is an unbalanced problem, you have to convert into the unbalanced problem, you have to convert into the balanced one. So how you convert them? So look at that. So there are the two cases. The case one, when the demands exceed the supply. Okay, that is, instead of the equality sign, it's a strictly less than sign. So what will happen? So look at the counter example. So assume that there are the two sources and the three destinations are there, and look at these are my cost 2, 4, 3, and these are supply. So look at what is the total supply. Total supply is my 30. What is the total demand is 40. Okay, so clearly the 30 is not equal to 40. So it means this is the unbalanced transportation problem. So this is the unbalanced transportation problem. So you have to convert into the balanced transportation problem. So how you convert them? Look at that. This is a 30, this is a 40. So there is a need to add the one extra row. Okay, so there is a need to add the one extra row with the supply 10. Okay, so it means so far you have the two rows 2, 4, 3 and 6, 1, 4. Okay, with the supplies 10 and 20, while the demands are 20, 20 and 20. So there is a need of adding one extra supply whose supplies of the 10 unit, but what about the cost? Okay, since the cost is totally depending upon them, if you add the another supply, it means you have to add the another source O3, but there is no source of them. So that's why whenever you are trying to convert the unbalanced problem to the balance, firstly convert into the balanced problem by using the dummy row, by using the zero cost. What is the meaning of that? Look at that. That is this. This is the original problem. This is my 30. This is my 40. So you have to add the dummy row. This is called as the dummy row. Okay, with the zero cost. While the supply is 40. Now it will be, look at that. So sorry, this is not. Yes, it's a 30. Okay, so it's a 30. So you have to add this is into balance one. So it will be now. It's here. Look at that. It's a 4. It's a 60. So again here is a 60. So now this is the balance one. Okay, so always remember, whenever there is an unbalanced problem, you have to convert into the balance problem by using either a dummy row or the column. Look at the second example. So when the supply exceeds the demand, okay, so when this one is there, for example here, look at that, what is the total supply is 100 and here is my 60. So again this is not equal to, so it means this is my unbalanced problems. So what will we do? So you have to add 40 here, so you have to add another destination whose value is 40 and the costs are 0. So again look at that, this you have to add another destination, that is a dummy column. Now this is 100 here and look at that, this is again 100. So again this is my balanced one, this is my unbalanced. Okay, so I again repeat that whenever you are trying to solve the any transportation problem, the first task is to convert the unbalanced transportation problem into the balanced transportation problem by adding a dummy column or by a dummy row, according to that whether the supply is less than of the demand or greater than of the demand. Okay, so what is the remark of that? Because this talk is about only for the introduction, that is the basic things are there. So remember, I just on the balance. So whenever you try to convert the unbalanced to the balanced one, so what is that? It has always a feasible solution. Okay, remember in the simplex method, whenever you are trying to solve the LPP like this way, there is no guarantee for that whether there is a feasible solution or not. Okay, but balanced transportation problem always has a feasible solution. What is the total number of the variables are there? So remember, these are my, if my m sources are there and destinations are there, so the total number of the variables are mn. Okay, and out of the mn variables, such as solutions are consisting of the m plus n positive variables at most. Remember, whenever you're trying to solve the simplex method, okay, so we always see that the number of the basic solutions are number of the base NCN. Okay, and the number of the non-basic solutions are, what is that, n minus m. This is the number of the non-basic in which whose values are 0. So what is that? This is my total number of the solutions. What is the, here in the transportation problem, what is the total number of the variables is mn. Okay, combination, what is the m is the rank of the constraints. Look at that in this here. So you call as this xij as a ai, and second is sum is my bj, and since it is a balanced one, so what is the total number of the variables? There are the m rows and there are the n columns, so total number of the constraints are this. But why we consider as a -1? Because there is a one more constraint is that is a balanced. So what is the meaning of the balance? That is ai is nothing but the bj, so it means one additional condition, so that's why m plus n minus 1. What is the, look at that, if I say x plus y plus z is equal to 1, so what is the degree of freedom? Total number of the variables are 3, but you need at least the 2 variables in order to find the third one. Okay, so it means that such a solution consisting of the m plus n minus 1, and the number of the non-basic variables are n. So what is the n is total number of the variables, and here, so look at that, this one is there. Okay, now, so these are the beautiful remarks. Whenever you try to solve the transportation problem, always remember that a transportation problem has a feasible solution, number of the variables are mn, and these are the feasible solutions. So now we know that a balanced transportation problem has a feasible solution. So what are those methods? Because we say that the simplex method is very lengthy method for solving the transportation problem. So what are those methods which can find the basic solutions, which can find the feasible solution? We call as the initial feasible solution. Okay, because remember, whenever you try to solve the simplex method, you start with the S1 and S2 or S3. Okay, here is 1 0 0 0 1 0. Okay, so these are called as the initial BFS. Remember, if you remember, the simplex method lectures are there, so these are the initial BFS. So same for the transportation problem, how you find the initial BFS. Okay, so for finding the initial BFS, there are the 3 methods. There are several methods are there, but generally the most important methods are 3. That is the northwest corner method, second is the least cost method, and third is the Vogel approximation method. Vogel approximation method is also pronounced as a WAM, W-A-M. Okay, so always remember again, unbalanced converted to the balanced, and only then these methods are applicable. So up to here in this video, I am not talking about these three methods are there. For to understand these three methods, I just put up the next video. Okay, so this video is only about the introduction of the transportation problems and to tell us that how you convert the unbalanced transportation problem into the balanced transportation problem, so that you are able to apply these methods. So I hope you may recall this lecture before able to understand this northwest corner, least cost method and the Vogel approximation methods. I again said that if there is any doubt, you can still ask me at any time. I'm more happy to resolve your queries. Thank you very much and best of luck for the students.